All right, guys, so we are back from the general Zoom break. So we are continuing from where we left off. So as I was saying, after we decide on what the variables are that we're going to be using for the amount of $5 notes or the amount of $1 notes, then now we need to formulate two equations. One would be x plus y equals 50. One would be 5x plus y equal to 74, all right? Now, what we're going to be doing now, based on the fact that the two equations have the same sign for y, then we subtract. And as I was saying before, if we had two negative signs for y, we would still subtract. So that's a general rule. Once the signs for the unknown that you're eliminating is the same in both equations, then you subtract. But if one is a positive in one equation and one is a negative in the other equation, then you will now have to add both equations together. Raise your hand if you understand clearly what I'm saying, guys. Okay, so in this case, because the unknown y has two positive signs in both, the signs are positive in both equations. So here we're going to be adding, sorry, not add, we're going to be subtracting one of the equation from the other. And generally when we are subtracting, we try to use the equation, we try to subtract the equation with the smaller values from the equation with the larger values, right? So in that way, it makes us work with positive numbers. If we subtract the equation with the larger value from the equation with the smaller values, we may work with negative numbers. And sometimes it's a little difficult for students to work with negative numbers. So I would suggest take away the smaller equation, the equation with the smaller values from the one with the larger value. So in this case, we would subtract equation 1 from equation 2. So subtracting equation 1 from equation 2, then what we would have now is that we would subtract x from 5x, we would get 4x. And then now we would subtract, so we subtract x from 5x, now we're subtracting y from y. Now if you subtract y from y, then it becomes 0, and that would eliminate the y. And now we would now have 74, and we are now subtracting 50 from 74. Remain how much? How much, guys?
24, sir.
Right. So now that we know that 4x is equal to 24, then you can get rid of the 4 beside the x by dividing that by 4. Whatever you do with one side, you do the same thing with the other side. So you divide both sides by 4. 4 cancel on the left. X remain by itself. And 4 into 24 on the right will give you what?
6, sir.
6. So in this case, x would be 6. Now what x being 6 tells you? Therefore,
That's $5 notes, sir.
so therefore, the number of $5 notes, or if you want to say the amount of $5 notes, is 6, right? Right. Now, because the question asks the amount of or the number of $5 notes, you need not really go further to solve for the amount of $1 notes. However, if the question should ask the amount of $1 notes, what do we need to do now? Guys?
Sir, but why now? The value of y when is 0 with a substitute.
What would we substitute?
The value for y, sir.
No, but we don't know the value for y. We don't know the value for y. Remember, that's what we don't only eliminate y, we didn't find a value for y. So that's what we're trying to do now. To find a value for y, we now have to put back x equal to 6 in one of the equations above.
Yes, sir.
So we substitute for x equal to 6 in the equation 1 or equation 2. And it is highly recommended that you put it in the equation where it is to calculate. And in this case, I would choose to put it in equation 1. Now, if you put it in equation 2, that wouldn't be a problem either, providing you do the calculation correct, right? But just for ease of calculation, use the equation, which is easiest to calculate. And so if we substitute x is equal to, if we substitute x equal to substitute x equal to 6 in equation 1, then we would get 6 plus y would be equal to 50. So now we can solve for y by just making y the subject. So to do that, we would take the 6 to the other side and subtract it from 50. So this would be 50 minus 6. So therefore, y would be equal to what?
44, sir.
44. So it means that you would have 44 $1 notes. Now, you could always check back the value for x and y by substituting both of them in one of the equation and see if you get the end result. So if you put y equal 44 in equation 1, sorry, in equation 2, and you put x is 6 in equation 2, so just plug in both the value for x and y in equation 2, and then we should get back 74. So for equation 2, we have 5x, so x is 6. So we would have 5 times 6. And then now we know that we have y equal to 44. So we would have 1 times 44. And then if we do the calculation, we will get 6530 plus 44. And then that will give us 74. All right, so that's how you can check to verify if your answers are correct. All right, guys. All right, any question about this? Is this clear to you guys? Raise your hand if it is clear, guys. Okay. What about you, Miss Caveira, I saw where you came in a little late.
Answer.
Are you following what we're doing so far?
Yes, sir.
Okay. All right. So let me move on to another question so that we can reinforce what we have learned. All right. So as I had mentioned, so we'll do the calculation x equal to 6. So therefore, 6 $5 notes were used, and that would have solved the question that they were asking. Here we have another example. And what I'm going to do is ask you to form the two equations. Because once you're able to form the two equations, then all you have to do now is to follow the steps that you use when you're solving simultaneous equations. So guys, I'm going to give you about 2 or 3 minutes to come up with two equations based on this, this statement. All right, guys, I'll give you a little time to do that. You may go ahead and do that now, guys. Okay, Ms. Caveira, you came up with any equations?
Yes.
All right, just tell me what you got for your equations. First and foremost, tell me the unknown that you're using. Define them for me.
Why?
When I say define them, tell me which unknown you're using for which number.
What do you mean by that, sir?
You need to define what you don't know. What do you know and what you don't know?
All right, we don't know the two numbers, but we know that their sum is 180 and their difference is 54.
Right. So what you're going to say from there, sir?
For the first equation, I have x plus y equals 108.
All right. Now, the problem with that, even though the equation might be x plus y equal to 108, you have to define the x and the y by saying let one number be x and the other number be y. You get what I'm saying?
Yeah.
Because if you don't make that definition, it means they're just going to wonder where did x and y come from? They just come out of the blue. So by you saying what you're using for your numbers, then that is how you're defining it. So let one number be x and the other be y, right? It's just a mathematical formality when you are using unknowns to say what you're using them for. Is that clear?
Yes.
All right, so let one number be x and the other be y. All right, so once you have made that statement, then now you can write your equations. All right, so what are they now? What are the equations now, Ms. Cabrera? So one of them is say x plus y would be equal to 108. The other one would be Miss Cabrera would be what?
X minus y equals 54.
So you would say x minus y would be equal to 54. All right, so anybody else got these two equations? Raise your hand. Okay. Some is with some got. What about you, Miss Green? Okay. All right, now guys, now that you have gotten the equation, you can go ahead and solve for x and y. All right, and then now when you're through solving, you raise your hand so that we can check your answers. All right, so go ahead now. Okay, let's see some. All right, so let us just give the others a little time to come up with their solution, and then we'll work it through together. All right. Okay, good, Miss Green. So, Miss Cabrera, we're waiting on you. Okay, all right. So, Ms. Waysome,
Yes, sir.
would you like to just tell me what the answers you get for X and Y?
X is equal to 81, sir, and Y is equal to 27.
X equal to 81.
And Y equal to 27.
Miss Green, do you get the same answer?
Yes, sir.
Miss Cabrera, did you get the
Yes.
same answer? Miss Cabrera, you cut off.
Yes, sir. Same answer.
All right, so clearly then, in this case, we first, what do we eliminate here, guys? Which of the unknown are we eliminating, X or Y?
Y, sir.
All right, so in this case, what we notice about the signs of Y?
One is positive and one is minus, sir. So in this case, we add.
Right. So once the sign of the unknown that you're eliminating different, one is a plus and one is a minus, then you add both equations together. And of course, the coefficients are and add. So x plus x will give you 2x. Now, when you add a positive value and the negative of the same value, they cancel out and give you 0. So now we will add 108 with 54. We would add 8 plus 4, give you 12, put down 2, carry 1. 1 plus 5 will give you 6. And then we will have 1 here. So now we would divide 162. Both sides we are dividing by 2. The 2 cancel on the left, leave x, and then the 162 divided by 2 will give you 81. So now that we know that x is 81, we can actually substitute x in one of the equations. So whichever one easiest to work, you put it in equation 2, you will have 81 minus y equal to 54. And so to solve for y, we would bring the 81 to the left. So we know that we have left with minus y on the left-hand side. And we will now have 54 minus 81. And so when we take away 81 from 54, we know that we are still owing some amount. So instead we take away 54 from 81, and 4 from 11 would give you 7, and 5 from 7 would give 5 from 7 will give you 2. So you get 4 from 11 will give you 7. So that would be 27. Negative 27, negative y equal 27. So now we divide both sides by -1. Or if you want to say you're dividing both sides by the negative. So if you divide both sides by -1, negative divided by negative give you positive. So on the left-hand side, you get positive y. Also on the right-hand side, you get positive 27. All right. All right, so that would be it for this one. So as we said before, we define our x and y to be the two numbers. Their sum would be equal to x plus y. Their difference is equal to x minus y. So all of this would be defining what we mean by sum and defining what we mean by difference. So now we would have the sum to be 108, and the difference to be equal to 54. And then now we can add both equations, and we'll get 2x equal to 162 divided by 2. So we get x equal to 81. Substituting for x equal to 81 in equation 1, we get 108 minus 81, so we get 27. All right, so that would be it. Now here we have another question, guys. I'm going to ask you again to try and formulate the equations from this question. The time might run out in about 9 minutes, so if it happens, then you can just log back in as usual. All right, guys? All right, go ahead and formulate the two equations. Finish, Ms. Waysom?
Yes, sir.
All right. All right, give the others a little time, and then now I'll just ask each of you to give me your equation. All right. Anybody else came up with any equation apart from the screen?
Sir, I come up with that equation, but I'm not sure if you're right.
Okay, what about you, Miss Green?
Yes, sir. Came up with an equation.
Okay. Ms. Waysam, can you share what you have with us?
Yes, sir. All right.
Go ahead.
So I said let X represent the foreman in each equation and Y representing the amount of men working together in each equation. So for the first one, I have X.
So X represent what? The number
The
of
foreman. Yes, sir.
bear with this writing, guys.
Sure.
It's not really the best. All right, so let X represent number of foremen or foremen.
Yes, sir.
And then now Y.
Y represents the number of men working together.
All right, so this will be the number of men.
Yes, sir, working together.
All right. Okay, so what's your equations?
The first equation, sir, a foreman and 7 men work together earn 1560. That would be X plus 7Y equal to 1560.
All right.
And then the
plus
7Y equal to 1560.
1560.
Yes, sir. And the other equation where 2 foremen.
Hold on, Miss Wilson. Did anybody else get this equation? Miss Green or Miss Cabrera, did you get this equation?
I did put the X and Y variables.
Say that again, Miss Cabrera.
So I just used the numbers. I didn't put any X or Y there.
Oh, you didn't put an X. Okay. All right. Part of it is important. You have to put in X and Y for the unknown. All right. Miss, who was that just now? Miss Cabrera or Miss Green? Okay. Miss Green, did you get this equation?
Yes, sir.
Okay. All right. Miss Waysam, can you give me the other equation now?
Yes, sir. So the second part where it says 2 foremen and 70 men work together. So that would be 2X plus 17Y equal to 3,660.
All right. So what would remain for you to do here now is give me the final answer that you get here. 2,000 what? 3,000?
3,660, sir.
660. All right. So now what you would have to do now is just to solve this equation. All right. How would you go about solving this equation, guys? Which one of the unknown would you eliminate?
I'm thinking to eliminate X.
Okay, all right. So before you can eliminate X, what you must ensure?
The coefficient is the same, sir.
All right. So what would you do now to get the coefficient?
Sir, I would in the first equation I would multiply the X by 2 and then the second equation by 1.
Okay. Well, once you already, it wouldn't be necessary to multiply the second equation.